Hello dear students, this is the second class of electrostatics. In our first class, we covered the topic of electric charge. Now, we will discuss about Coulombs law or force between charge particles. So let us discuss about Coulombs law. Coulombs law, it states that the force between 2 point charges at rest is directly proportional to the product of the magnitude of charges and inversely proportional to the square of the distance between them. So let us suppose we have 2 point charges Q1 and Q2 and the distance between them is R. So according to Coulomb's law, the force between charged particles is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. If we merge both the equation, then we can write F is directly proportional to Q1 Q2 by R square. If we remove the proportional sign, then we can write a constant. In this case, this constant is called small k, electrostatic force constant. So, we can write F is equal to k Q1 Q2 by R square. In place of k, also we can write 1 by 4 pi epsilon naught, where epsilon naught is permittivity of free space. Its value is 8.854 into 10 power minus 12. So, what is K? It is electrostatic force constant. The value of K depends upon two things. Number one, nature of medium, means what medium is between the charged particles, air, glass, water or some else. Number two, system of units, means whether we are calculating in SI or CGS or some else unit. The value of K in air is 9 into 10 power 9. Now, our next thing is 1 coulomb. So, what is 1 coulomb? According to the Coulomb's law, we know that the formula of force is given by F is equal to K Q1 Q2 by R square. In this formula, if we write Q1 is equal to Q2 is equal to Q, the distance is 1, force is 9 into 10 power 9, then we can get the value of Q is equal to plus minus 1. So what is 1 coulomb? It is a charge that repels similar charge with a force of 9 into 10 power 9 Newton when placed in air at 1 meter distance. So that is the definition of 1 coulomb. Now we will discuss some units of charge. So 1 coulomb we can write 3 into 10 power 9 state coulomb. What is state coulomb? It is the CGS unit of charge. Next unit 1 microcoulomb, we can write 10 power minus 6 coulomb. Next unit 1 nanocoulomb, we can write 10 power minus 9 coulomb. Next unit 1 picocoulomb, we can write 10 power minus 12 coulomb. So these are the units of charge. Now we have some important things related to Coulomb's law. Number 1. Coulomb's law is valid only for point charges. So when the charges is very big, the Coulombs law is not valid. Only it will valid for point charges. Number 2, Coulombs law is valid only for rest charges. If the charges is in motion, then Coulombs law is not valid. Number 3, it is not a universal law. So we cannot apply Coulombs law in all over the universe. Now, next thing we have permittivity. So what do you mean by permittivity? Permittivity is the property of medium which determines the electric force. Let us discuss about it. So we have relative permittivity. So according to Coulomb's law, in air or vacuum, we can write F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Or in medium, we can write 1 by 4 pi epsilon naught into epsilon R Q1 Q2 by R square. Or in place of epsilon R, we can write capital K. Here, epsilon naught is called permittivity of free space. Epsilon R or K means dielectric constant or relative permittivity. What is relative permittivity? It is the ratio of force between two charges placed in air to the force between same charges placed in medium. So relative permittivity is the ratio of force of vacuum to the force in medium. So it is a kind of ratio. So we can write epsilon R is equal to K is equal to epsilon upon epsilon naught is equal to F of vacuum upon F of medium. The value of K in air or vacuum is 1 and in water is 80. Now we will discuss about superposition principle or force between multiple charges. What is it? It states that the net force acting on a given point charge due to number of charges is the vector sum of individual forces acting on that point. So let us suppose we have a charge Q naught at this position. We have some other charge Q1, Q2 and Q3 in that position. So according to Coulomb's law, force will applied on that charges, these charges and that charges. So let us suppose the force between Q naught and Q1 is F1. The force between Q naught and Q2 is F2. And the force between Q naught and Q3 is F3. So according to the principle of superposition, the net charge on Q naught is given by the vector sum of this force and this force. That means F1, F2 and F3. That means we can write the net force on Q naught is given by F is equal to F1 plus F2 plus F3. So that's all for today's class. In our next class, we will discuss about numericals of force. Thank you.